Now here we are going to write the main program. Now coming to this main program, here I have shown you the steps how to write the program. Now coming to this main program, how to write means either you can write in your examination, lab examination, or in your theoretical paper. So this is your operation, or you can first comment the task, comment. COWNENTS comments or explanation. And here the last I will take this is the operation. Which operations are going to form. Now suppose we have the memory location. This is suppose a memory block I am showing here and started from 2008 to 200 FFH. Right. So in this memory location, what we are going to write? We have to choose the particular memory location. We have to choose the particular memory location where we want to store start our program. Suppose 200H. The very first thing we have to take two random data. I told that to take two data. So individually I have to take. So suppose if I take MBI A, suppose 07H. I am taking two data. One is A equals to 07H and B equals to 04H, or simply say 02H, right? So these are the two data. I have two different registers I have taken here. One is A, another is B. You can take any two different registers among the six random registers, that is B, C, D, E, H, L. Don't take F because F is a flag register which is used to provide the status of a program. And B is 0 to 8. So whenever I have written MBI 07, that means earlier I told you this is a 2-byte instruction, and the first will be one more thing. This is output, and suppose here if I take this data byte. So the first thing MBI is the output of code of MBI A will be loaded in this 2000 location. And then next the data byte. So this is also, so here this data byte is 07H. The data byte. Always remember that the very first memory location we need to provide the opcode. Until and unless you get the operational code, how do you say this, which operations you are going to do? Then you have to take the operand. The data byte. So for this first cases, MBI 07H, if I say the commenter expression, this is your data byte, this data to destination. Destination register is A. RD. Destination register. Destination register. So in this destination register, what you are going to do? From this data 07H data would be moved immediately. MBI means moved immediately. Move immediately. Move means nothing but the copy. Move immediately. The data 07H, the data byte. Rather than saying data only, data byte, say data byte 07H into accumulator. So this is your explanation of comment. Now operation, so here you will get A equals to 07H. A equals to 07H. Now if I tell you, we have the register. If I can show you the register sections, here this is the register section of 8085. MIPI means microprocessor. So AF, this is B, C, this is D, E, H, L, Then these are the two SP and PC, right? So after execution of these instructions, so that means in this 200H, what I got? We got the opcode of MBI A. And in 2001H, what we got? We got the data byte 07H. The data byte 07H. Right. So after execution of this instruction, what you will get? A equals to 07H. The data 07H will be loaded here in this accumulator register. So from these two data bytes, we have taken one data byte. Now, so the next location obviously here I have to take one more. If I take already I have taken B register, you can take any C register, D register, E register. So I have taken B register. So MBI that is 02H. Again there is one more instruction, that is a 2 byte instruction inside this, and this also move immediately the data byte 02H into B register into B register, right? So for this two, again the first memory location is next memory location will be 2002H. In this 2002H, what you will get? The opcode of MBI. And in this next memory location 2003H, what you will get? 2003H, the data byte that is your 02H. 02H. So this will be the explanation written here, because this is the space wider space I'm getting here to make you understand it will be much better. And that is why I written. So the operation after execution of this instruction MBI B, 02H. So the B register will be loaded with 02H immediately. So that means in this 2008, 2002H of code of MBI B. And in 2003H, this will be your the data byte, second data byte. Obviously, that is 02H. Right. So we got our two data byte. Now we can do addition operation. And I already told you, whenever you are going to do any kind of operations, among these all 5 types of instructions, means arithmetic instructions or logical instructions, arithmetic instructions, any operations and operations are going to perform in this accumulator section, and they also will be holding temporarily the result also. So that means already in the accumulator, if I say this accumulator section, this is your suppose accumulator section. This accumulator already is your loaded. Now to add one more data, you have to put it into the accumulator. That means the left second data byte that should be added with the accumulator. So added with the accumulator. For this things we will write add. If I write add or B, no, add only B. Add B. Add B means the content of or the data byte of B register. The content of the data byte of B register will be added with the accumulator content. See, this is only a single mnemonic, there is no other such kind of data byte. So it is only the opcode itself. So that is this only one byte. So this is the opcode of add B. So that means only one memory location you need. So in this memory location you are going to do add B, the opcode of add B. And the operation, if I come to this operation, here nothing will be there. So here it will be A equals to A plus B. A equals to A plus B. That means in this 2004H, Memory location what I will get 2005 memory location, the opcode of and B, the opcode of and B, and here you got the result, that means A equals to A plus. So now after execution of this add B, initially that was A equals to 0.78. So after the execution of add B, what will happen? A equals to 0.7h plus 0.2h. So that is 0.9h. So now A will be updated with 0.9h. So now this A will be updated with 0.9h. Right? So here this is the result we got with the calculator. Now you have to say whether you want to see this result in a different memory location. If yes, then you have to take STA any location. Suppose I want to see the output or result in this memory location. See, I told you this STA2050 is nothing but this is a 3-byte instruction. STA2050. So for this is your output. So 3-byte instruction means 3 different memory locations. That is your 2005H, and then 2006H, and then 2007H. Right. So in this 2004H, it will be the output of STA. So here it is 2005H, the opcode of STA. So in this next memory location 2006H, 2007H. Now this next memory location 2006H, the lower order address byte. Lower order address byte means this 50 first, 50, and then the higher order address byte. Higher order address byte means that is 20H. So for this next location, what you will get in this 2006H, it will be 508, the lower address byte, and this 2007H, the higher order address byte, the higher order byte. Now here, the comment expansion already, it will be, the comment will be here, store the content of accumulator. Store the content of accumulator in 2050H memory. That means now in this 2050H memory location, what is our 2050H memory location? Suppose these are 2050H memory location. In this 2050H memory location, the result, the content of accumulator, the last content of accumulator, obviously this is the result. The content of last content of accumulator is the result. Now we have to stop the program. And for this, we have to write this HLT halt. So that is 1 byte again instruction. So halt means here only the opcode of halt. Opcode of HLT. And this means the expression will be terminate or stop. Terminate, stop the execution of the program. Stop the execution of the program. Stop the execution of the program. This is the end of this program.